Hey math kids, today we're going to talk about the tangent function, and let's just jump right into it. So remember, let's see, it's not drawing. So remember that if we take sine theta, we go over cosine theta, that's equal to tangent. And so we can't have division by zero. So whenever cosine equals zero, which we have a few places where that happens, right? So we have that at pi halves, and we also have that at 3 pi halves. Just think of the unit circle. So the unit circle, the x value right here equals 0, and that's our pi halves. And then the x value right here also equals 0, and that's our 3 pi halves. So for those two spots, we have division by 0. So when we draw our tangent, we know we're going to have a vertical asymptote at those two places. And tangent looks kind of strange. So it looks like this. And then there's a vertical asymptote. And then we go like that again, and it just keeps repeating. And the period is actually only pi. So for sine and cosine, the period is 2 pi, but for tangent, it's only pi. And so this first spot where it happens is pi halves, where the asymptote happens. Right here is 3 pi halves, etc. Now, we think of the period being from 0 to pi. So if we're only drawing from 0 to pi, tangent looks like this. Because that's pi right there. Okay, so the rest of this thing, this video is just going to basically use this as a parent function and then move around tangent and see what happens. So it's going to be very similar to the other videos on sine and cosine. Okay, so we are given y equals tangent of x plus pi fourths. And it wants us to graph it in between 0 and 3 pi. So when we do that, just graph our standard function first. And let's see how far that takes us. So we get 0 to pi right here. And if we go from there to there, this would be 2 pi. And then if we go one more, 3 pi would be right there. Okay, now that's just standard tangent. That's not tangent pi fourths. But what we would need to do is just take everything and move it this direction by pi fourths. And so essentially we're just going to take this piece, move it here. So we have that, and then our asymptote's here, then etc. It's going to be just shifted over, right? Now, I think the only thing I'm going to have you be exact on are the asymptotes, because that's kind of one of the defining characteristics of this. And so this asymptote on, not that one, sorry, yeah, that asymptote, the purple one, is on regular tangent is at pi halves. And so if we shift that to the left by pi fourths, we're going to get pi halves minus pi fourths. And so that's going to be 2 times 2. So we get 2 pi minus pi. And those are both over 4. So 2 pi minus pi would be 1 pi fourth, or just pi fourths. Okay? So this new asymptote right here going to be at pi fourths. Okay. Now, the other asymptote is normally at 3 pi halves. And so we'll go through the same process. 3 pi halves minus pi fourths. Multiply this by 2, multiply this by 2. So that's 6 pi minus pi all over 4. So that's 5 pi fourths. So this new asymptote right here would be at 5 pi fourths. And if we go through the same process, we see that this, our other new asymptote, that would be about right here, is going to be at 9 pi fourths. So I'm going to have you just label those values, and we'll call it good on that example. Okay, we have one more example, and they want us to do y equals tangent of 2x, and they want to do in between negative pi and pi. Whoops, that should be an x. Okay, so 2x is going to, it's considered a horizontal stretch. And so if we draw like our original tangent function, that's pi. That's negative pi. Okay. I know that's kind of a messy drawing. You can always look in your book for a better drawing if you want to see that. And what's going to happen with this is anything that happens inside of parentheses is counterintuitive. So just like on the previous problem that we did, this said plus pi fourths, which makes us think going to the right, but it actually goes to the left because it's counterintuitive. Now when we're down here, we're multiplying by 2 as far as our x is concerned. But actually in the problem, we're going to divide everything by 2. So let me label, so this was pi halves on the original, this is 0, and this is negative pi halves. Okay, so all we need to do is actually divide all these by 2. So that becomes pi halves, this becomes pi fourths, this becomes 0 over 2, which is still 0, this becomes pi fourths, and this is pi halves. Now, we didn't spread out enough because we need to go from negative pi to pi. And so in the original, this would have been 3 pi halves, and this would have been 2 pi. But if we divide those both by 2, that's 3 pi fourths, and then the 2's would cancel here, and this gets us to the pi that we were hoping for. And so we can do the same thing on this side, where we go like this. Oh, I do have some room. Cool. So this goes like this. Goes like that. Oh man, that's a bad tangent. Let me try it one more time. So we're gonna go like this and like that. Okay, that's better. And so just like when we went one more out this direction, one more out this direction is going to end us with negative pi. If you need additional help, come to Math Lab. Until then, calculator.